All right, hi guys, welcome to your Unit 8 review. So number one, a curve is defined by these parametric equations. We have x of t, y of t, find dy dx in terms of t, simplify it down the whole way, right? So we're going to do dy dt, so derivative of this one, that would be 5e to the 5t. And then we're going to do dx dt, this would be 9e to the 9t. And then whenever you divide, you're going to subtract your exponents. So it'd be 5 minus 9, it would give you -4. Or you could just put that in the denominator. So it'd be e to the 4t. Oh, and I need that minus. So 5 over 9e to the 4t. So we're just simplifying these exponents. All right, number two. A curve is defined by x of t, y of t, and then we're given both of those equations. Find the second derivative. Okay, so first let's do the first derivative. We're going to do derivative of y, that would be 2t. And then derivative of x, that would be 4t cubed. And I'm going to simplify that down before I do the second derivative. So 2/4 would reduce to 1/2. And we'll have t squared in the denominator. So now we're going to do the second derivative. So it's the derivative of this. So let me rewrite that. That would be 1/2 t to the -2. So if you do that derivative, multiply this down, you would get -1, and then you would subtract this further. So it would be t to the -3rd. So we're going to have -1 over t to the 3rd. And then that's going to be over the derivative of x again. So 4t cubed. And so I'm going to bring this t cubed down to the denominator. So this would be -1 over 4t to the 6th. All right, so number three, if f is the vector valued function defined by, and then we're given that, find the derivative. All right, so we're just going to do the derivative of each parts of this. Derivative of cosine would be negative sine. And then we're going to have to do chain rule, multiply on another 6. This would be -18 sine of 6t. And then derivative of sine would be cosine. And then chain rule, we're going to have to multiply on a 9. So -18 cosine of 9t. And that's all we were asked for there. So that's all that we have to do for that one. All right, I'm going to try to pause after each question so there's not all that dead space while I'm flipping the paper over. All right, let f be this vector defined function. Find the derivative at -4. So we're going to do the derivative just like we did in the previous problem, and then we'll plug in -4 to that. All right, so this derivative would be 6 minus 3t squared, and then 4t cubed. And then we're going to plug in, what was it, -4. So -4 squared would be 16. You know what, actually, we can just leave this. I'm not even going to deal with it. I'm going to just put -4 in there. That would be 48. Then you'd have to do 6 minus that, but you can actually just leave it alone. All right, so number 5, a particle has a velocity vector given by this. What is the particle's acceleration vector at time 5? All right, so acceleration is the derivative of velocity, and then we're going to plug in 5. So actually, it's the exact same thing that we did in number 4. We're just using the words velocity and acceleration. All right, so derivative of a natural log, it would be 1 over whatever you have. So that t cubed minus t is going to go in the denominator. And then we're going to chain on the derivative of that. So I'm going to put that in the numerator. So 3t squared will go in the numerator. Oh, -1. 3t squared minus 1. All right, and then derivative of this part would just be 2t. So that one was a good bit easier. And then we're going to plug in 5 to that. And again, you can just leave this alone. 5 squared would be 25, times 3 would be 75, minus 1 would be 74. But again, you could just plug in 5, like you could just leave it like this. And then 2 times 5 would be 10. So simplify as much or as little as you want there. So for number 6, a curve has these parametric functions. the coordinates of the point when at time 7. So be careful, it's not starting at time 0. You can start at whatever time you want. We're starting at time 7. T equals 7 is this coordinates. That's our initial condition. What are the coordinates at t equals 3? So we're going to have to do the x and the y separately. So let's do x first. X starts at 7, and then we're going to add on its displacement. So again, not starting at 0, we're starting at 7, and we want to go to 3. And this is, that rate is 4t dt. So let's work this out. This would be 7 plus, all right, that antiderivative would be 2t squared. And then we're going to do upper boundary minus lower boundary. So let's see, 3 squared would be 9, double that is 18. 7 squared would be 49, double that is 98. So let's see, oh, you know what, you're allowed a calculator for this test. Why am I trying to do all this in my head? So it'll be negative 73. I do want to see the antiderivative though. This is fundamental theorem of calculus, so I do want to see that because I want to make sure you can actually work that out by hand. All right, and then for y started at -1. And again, t starts at 7. We want to go to 3, and that rate was 8t cubed, and then dt. So this will be -1 plus, all right, antiderivative. This would be 1/4 t to the 4th, but we already have an 8 there. So 1/4 times 8 would be 1/2. Oh, no, I'm sorry, 2. 2t to the 4th. All right, such that 7 to 3, and then we're going to do upper boundary minus lower boundary. So 3 to the 4th would be 81. Double that would be 162. And then I don't know what 2 times 7 to the 4th is. Let me type that in. That is 4,802. And then let me add all this together. So I got negative 4,641. So these are our coordinates for x and y, and so this is your final answer. All right, so for 7, there are all these parts to it. We're gonna use this velocity vector. Time goes from 0 to 8 seconds, measured in meters, and at time 0, so this one actually does start at 0, position is 3, -5. So letter A says write an equation of the tangent line at this time 0. So this is our, we're gonna need a point and a slope. This is our point, 3, -5. And then slope comes from the derivative, which this is velocity, so that is our derivative. And we're gonna just need to plug in time being 0. And it'll be dy dt over dx dt. So this over this, we're gonna plug in time 0. So e to the 0 would just be 1, 2 minus 1 would be 1. And then for dx dt, plugging in 0, cosine of 0 is 1. Times 2 would be 2, and then 1 minus 2 would be -1. So our slope is -1. And then you just put that together into your equation. It'll be y plus 5 equals -1 x minus 3. All right, so letter B. What is the first time the line tangent to the path of the particle is vertical? Vertical would be when dx dt equals 0. So we're going to take this equation and set it equal to 0, and then solve that. So we're going to subtract over the 1, divide by -2, so that'll be 1/2. And so we need to think about our unit circle, and it says the first time. So going around our unit circle, we need the first time when cosine equals 1/2. Cosine is the x value, so 1/2 would go here. That means this would be square root of 3 over 2. This is not to scale. And that would be at the angle pi over 3. So we're going to have 3t equals pi over 3, divide over the 3, and we would get pi over 9, time was in seconds. So it said vertical tangent line, that's when dx dt equals 0, and then we just solved that. All right, letter C, find the position of the particle at time 3. This is really similar to one that we did earlier where we're going to have to do x and y separately. So x, we're starting at 3, And in this case, time actually did start at 0. So we want to go from 0 to 3. And this is our rate equation that goes in the integral. All right, so working that out, we're going to have 3 plus, all right, this would be t. And then I need a function that if I did the derivative, I would get cosine. And so that would be sine. And I would need, this would be a u substitution, but if it's a real simple one like this, you can just put the adjustment in there. We would need an adjustment of 1/3. So this will be 2/3 sine of 3t such that, and then 0 to 3. So we are going to do upper boundary minus lower boundary. So plugging in 3, this would give us 3 minus, all right, let's see. 3 times 3 would be 9. I'm just going to leave that as 2/3 sine of 9. And then plugging in 0 is going to make all of that go to 0. Sine of 0 is 0. So this would just be 3 plus 3, I can add that together. This would be 6 minus 2/3 sine of 9 for our x coordinate. And then for our y coordinate, we're going to start at -5. And again, time was actually starting at 0 this time. And we want to go to 3. We're being asked, where is the particle at time 3 seconds? And then this is our rate that goes in there. So this will be -5 plus our antiderivative. This would be 2t minus 1/4 e to the 4t, and then such that 0 to 3. So it'll be -5 plus upper boundary minus lower boundary. All right, if we plug in 3, we're going to get 6 minus 1/4 e to the 12th. And then if we plug in 0, this part would just be 0 minus 1/4. And so we want to put this as an ordered pair. I'm going to type it in the calculator and get the decimals for writing it as the ordered pair. I still want to know that you can work out the antiderivatives, but I'll just go ahead and get a decimal answer for this one. So when I type this in the calculator, I get 5.725. And now I'm going to type this one. All right, and I got, oh, that's a big number, -40,687.447. All right, letter D, find the acceleration vector at time 2. All right, so acceleration is going to be derivative of velocity. So derivative of cosine would be negative sine. Negatives are going to cancel. So this will be 2 sine of 3t, but then chain rule, you'd have to multiply on another 3. So it will be 6 sine of 3t. And then derivative here would be -4e to the 4t. So just don't forget about chain rule. And then we're going to plug in 2. So this would be 6 sine of 6. And this would be -4e to the 8th. All right, letter E, find the speed of the particle at time 7. That's this great big square root. You kind of just need to remember this formula. It's going to be velocity of x squared plus velocity of y squared. These are the velocities, so we don't need to do anything to them. We just need to plug in 7. So it would be 1 minus 2 cosine of 21 squared plus 2 minus e to the 28th squared. And then I'm going to put that in the calculator. Oh, and this came out to an enormous number. So this came out being written in scientific notation. This means times 10 to the 12th. So I'm going to write 1.446 times 10 to the 12th. So just, you know, an absolutely enormous number. Include units. it's a rate, so it would be meters per second. You know, I made up this problem, so it turned out a little strange. That's a very fast speed. All right, letter F, write but do not evaluate. I love when it says that. Write but don't actually work it out. An integral expression that gives the total distance traveled by the particle in the first 8 seconds. So it'll be integral 0 to 8. And then it's kind of what we just did in the previous problem, except we're not plugging in a number. It's just going to be this squared plus this squared underneath that square root. And then dt at the end. And you don't have to do anything to that because it said set it up, but don't evaluate it. So that's it. All right, and then last one, letter G, find the average speed. This is like average value that we did. If I gave you a list of numbers and asked you to average them, you would add them all up and then divide by however much you've got. An integral is what adds it all up. So it'll be integral 0 to 8. And out front, we just put 1 over 8 minus 0. And then same thing, gigantic square roots, and then all of this squared plus all of this squared dt. And we're gonna plug that in the calculator. So let me go ahead and type that in. It's having to think about it. There we go. All right, this one's also really large. It came out to another one in scientific notation. It's 2.467 times 10 to the 12th. It said include units, so it's meters per second. I'm sorry it turned out that way. I made up this problem and it just came out to like astronomically large numbers. So I apologize about that, but just go with it. That's what it came out to. So that's the answer that we get.